I want to walk through a real cool example of a parabola. So doing the geometric representation, so the definition of a parabola from geometry, using that with the calculator to derive the parabola and then figure out its algebraic formula. So tying in the geometry of the parabola with our algebraic formulation. So what we're going to be doing, I'll work off of a document, and I've got this with all the steps. But we'll start with the basic definition that a parabola is a set of all points that are equidistant from a point called the focus and a line called the directrix. So if you look at the construction here, the locus of that point P as the point moves along in the directrix is going to be how we calculate the parabola. So a lot of times we start with the algebra and then we come to this later, but this is just sort of reversing thing. Let's start with this geographic definition to see how this really gets constructed. So let's go to the calculator and do that. So first of all, we're going to put a point which is going to be our focus. So we'll create a point. We're aiming for this point to be 2, 5, so I'm going to get it close there and then figure out what that point is. I'm going to call this, I'm just going to call it point F for the focus. And then let's figure out that coordinate. So menu, actions, coordinates, and equations. Let's figure out the coordinate of this point. So it looks like this point is 1.51, 4.97. So we're going to switch that. So I hit escape, and I want this to be point 2, and I want this to be point 5. And there we go. So I've got the point 2, 5. This is going to be my my focus point. Now the next thing I'm going to do is graph the directrix. So we're going to graph the directrix, the line y equal 3. So I'll hit the tab key and just graph y equal 3. But what I need to do from a geometry standpoint, or the geometry within the TI, is to create an actual line or a line segment that goes through there. So I really need to cover that up. So I'm going to go menu, and then I'm going to create a points and lines, and I'm going to create a line, and it's going to be just make sure that the points fall on the graph of what you had before. And so that is all there. So I've got my line graph, which is the directrix, and I've got my point, which is there. Now what I want to do, I want to create a segment. So I want to create a segment that goes from anywhere, from the focus to anywhere on this line of the directrix. So I want to create that line segment first. So let's go ahead and do that. So that will be menu, and we're going to create a line segment. So it starts at the point 2, 5, and it lands somewhere on this line. And I'm going to call that point Q. Okay, so I've got point Q on this line. Now what we're going to do is move this label around a little bit. For this line segment FQ, I'm going to create a perpendicular bisector. So menu, construction, perpendicular bisector. And then what I need to do is to select this line segment, and now that creates the perpendicular line sector, perpendicular bisector for me. Now the parabola is going to be the set of all points equidistant from this point Q and point F. So somewhere it's going to intersect this perpendicular bisector. So what we want to do now is to create those and find that intersection point. So on the directrix, I'll need to create a line that's perpendicular at Q. So I need to create a perpendicular on this line, and it needs to also intersect the bisector. And let me back up. So let's try that again. It needs to intersect this line and also the perpendicular bisector. Sorry, a little hiccup there in creating that perpendicular. So what I need to do again, it needs to be perpendicular to the line, y equal 3, and through this point Q. And then that gives me the perpendicular that I need. Now what I need is that intersection, so I need where this perpendicular intersects the perpendicular bisector. So with there, I'll go to points and lines, and I'll find the intersection points, and I need to find where this perpendicular intersects this perpendicular line here. And you'll see that point right there. And I'm going to label that point Z. So if I come over here to this point, and let's just go to menus. So just label that point Z. And there we go. So now to finish the triangle, I'll just need to create another line segment. So create another line segment that goes from point F to point Z. And now my triangle is complete. Now you can have discussions about this triangle. So you see that, obviously ZQ and FZ are identical by definition of the parabola, the equidistant points from the focus and the directrix. That makes that triangle, with two equal sides. You've got the perpendicular bisector, so you've got these triangles are identical, so you've got a lot of geometry that you can talk about there in terms of what's been constructed. But now what's going to happen is we're going to move point Z around, and point Q, and then wherever Z goes, that is going to draw my parabola. So you're moving on a straight line, and you've got a triangle, and as that moves, that's creating the curve, which is your parabola. So what I want to do to make it a little bit easier to see is to create a locus that does that for us. So menu, and if I go to construction, and I go to a locus, I select point Z, and then point Q. And I see the locus. Now if I were to move point Q around, you can see exactly where it moves. So you see it moves along the parabola that I've just created. Now what I want to do is we want to say, okay, let's look at that in a list and spreadsheet and see if we can come up with the equation of that parabola. So what we need to do, we need to get this point Z, and we'll need to get the coordinates and have those coordinates load into a spreadsheet. So I'm going to go over here to Anal Actions, Coordinates and Equations. So I want to get the coordinates of point Z. And I've got that on my graph. Let me move the graph over just a little bit. And what I want to tell it to do, I want to create variables to contain point Z. So that would be the next step, is to create variables. So what I would do in that case is, I'll store a variable for the X coordinate and a variable for the Y coordinate. So let's select this coordinate, and I'm going to say control var, which is going to store that, and let's just call that my X value. And then I'll do the same thing with the Y coordinate, control variable, and store that in Y. So you see those are bold now, and I've got variables that now represent the coordinates of point Z that's going to move around. So now I'll just go and create a new list and spreadsheet, and I'm going to have X value, let's just call it X value, and Y value. And then to create these values, I need to put the data in that I had from the previous variable. So I'm going to have it capture from these particular variables. So you'll see menu, data, data capture, automatic, and the variable that I want it to capture is going to be variable X. x, and then same thing for the y variable. So menu, data, data capture, automatic, y. So now this should correspond 6.5, 9.1. Those are the initial points that I have for point z. Okay. So now what I'm going to do, I'm going to go back to my graph and do what we did a moment ago. I'm going to move this around. And it should be gathering all of these data points. You can move your graph around. You can grab, go a little bit further. Get a good representation of what this parabola looks like. Go back to your spreadsheet, and now you see all the data that I've collected for points that must lie on this parabola. So let's create a new graph page. So control document, let's create a new, sorry, not a new calculator. Let's create a new graph. And what I want to do now is to have a scatter plot of the data that I just collected a moment ago. So I go over here to menu, graph type, scatter plot, and then it's going to be from the spreadsheet. I had x value and y value, and there you see my scatter plot. Let me bring it down. So there we go. So this is just from the data that was gathered from the spreadsheet. Now it looks like what we expected to look like. It looks very similar to the parabola that we thought we would get, but this one has the real data values. Okay, so I've got the spreadsheet here. What do I do now? Let's try to see if we can figure out what the algebraic function is here. So let's just go back to our graph type and let's graph a function now. So is it x squared? You know somewhere in your life that that's what a parabola is. Okay, it has similarities to x squared, but it's not exactly x squared. So it looks like maybe this vertex needs to go a little bit higher. So I'm going to move this label down. So let's just see, maybe if we move it a little bit more, and we'll go there. Let's look and see if I make it a little bit wider. It looks like I get a better representation there. Okay. So that looks like a fairly good representation of the line. F of x is 0.25, x minus 2.02 squared plus 3.96. And it's going to be hard to get exact, but in the spirit of nice round numbers, it looks like, maybe this is 0.25 x minus 2 squared plus 4, if everything's going to be nice integers. What we can do now is just figure out, okay, let's do quadratic regression to figure out what is the exact equation from the data. So menu, statistics, stat calculations, quadratic regression. So that was what, x value and y value. Say okay. And it tells me that, okay, here is your exact. It is 0.25 and then x squared minus x plus 5. So a little bit different than the one that we saw. So let's go see, well, what if we were to graph that? What would that look like? So let's go back to our graph page, and let's just see if we were to graph. And I can recall, it has the regression line already in there. I don't have to type that in. So just by hitting the up arrow, the regression, not regression line, but the regression quadratic is there. So I graphed that. So now you see the black line. So now you've got three things superimposed. You've got the regression that comes from the data, you've got the data itself, and you've got the approximation that we drew ourselves. So these are all pretty much lining up to be very close to what this parabola is going to be. Now you can sort of switch gears at this point. I've got instructions, but you can come down and let me just skip through several pages, and you can just say, are these the same? So it looks like we are thinking that this is what we derived when we did the formula ourselves, and it looks like with the regression, this is what we got. Are these the identical functions? You can go through the algebra to determine that those are the function. Now where you could go from here, this needs to be formatted a little bit more, but you can just go to a more general form. You could say, well, let's derive the formula ourselves from the distance formula. So I know that the distance from z to q has to equal the distance from z to f. Well, in this case, I know the distance from Z to Q, if that's point xy, it's going to be y minus 3. So y minus 3 equal the distance from xy to 2, 5. Use the distance formula and you'll come up with the same equation. So anyway, pretty cool there. Now, probably to get a little bit more involved than certainly CP or EP, you could take it further. You could generalize the formula and say, okay, well, what if I had something that looked like this? Parabola at the vertex and a directrix. How could I derive that formula? And to get it even a little bit more involved in the algebra, you could take a general form and say, let's derive that for all general cases in vertex form. So a little bit more involved there. But anyway, hey, I just wanted to record this real quick so that would remember what I did when I learned this, and pardon some of the mistakes as I went through. But I've got a document that goes through it. But I think this is a real cool example of using the calculator to tie in geometry and algebra for a particular thing that we cover. Thanks.